Here's some slides on your objectives for this chapter. I'm not going to cover a lot of the information that doesn't have an actual purpose in refrigeration and air conditioning repair. Some of the theories and laws of gas, unless you're an engineer or creating units, you really don't need to know these. And I've known some refrigeration chemical engineers that do this every day, and they really don't use these laws as much as this book would have you think. But I'm going to go over the items that you will need to use and why we use them. Volume. Physical space occupied by a substance. Can be measured in liquids and solids. Increases when the substance is heated, decreases when it's cooled. Now we see this. This is our refrigeration principle. Very key point here is that when you heat up refrigerant by compression, which the compressor does, it's a high pressure, high temperature gas, and it decreases in volume. It increases in volume when it's heated, which is the compression cycle, and decreases when the substance is cool, like going through the condensing coil. Heated gas in a fixed container, the volume increases until the container is full. Additional heat and energy increases pressure and temperature. So what it's saying is you can only fill the container with so much volume. I mean, unless the container breaks, but then it's not in the container anymore. The only way to change this is by heating it or using heat energy to increase the pressure and temperature, which is, again, what we do in refrigeration. When you're going through copper coils, the coils can swell a little bit. But once the volume is set at the volume, we change or manipulate the refrigerant by putting heat to it or taking heat away from it to make refrigeration and air conditioning work. Pressure, force per unit of area. U.S. customary units is pounds per square inch, or the Pascal scale, SI scale. They're different. We're not going to actually look at these other scales and use them in refrigeration, except for one little mention later on. But we're going to use U.S. customary units. All substances exert pressure on a surface supporting or containing them. For example, the pipes, or copper tubing, or aluminum tubing in an air conditioning system. Formula of calculation pressures. We're not going to learn the math here. We're not going to do any math questions using this formula. But I just want to use this slide to illustrate air conditioning or refrigeration, how it works. That center little cylinder that you're looking at, the blue one, it says if force increases, pressure increases. Think of that as a cylinder in an air conditioning system. The cylinder fills with refrigerant gases. The piston pushes up, and we've seen this in an earlier picture, and it increases the force, which increases the pressure in there. If that piston went back down without exhausting the high pressure, high temperature gas out of the cylinder, then you'd end up with the next little box on the right-hand side that says, if an area increases, pressure decreases. So that piston comes back down, giving the refrigerant more area to use, the pressure is going to decrease. It doesn't stay at that same pressure. So this is part of Pascal's law, which I don't expect you to memorize or do the math on. But just to show you, this picture is of a cavity full of refrigerant, and there's 3 gauges around the outside and the piston at the top. And it shows you that there's 60 pounds of pressure pushing down on that piston, which is filling the box and the gauges with 60 psi. If you put 80 psi in and push that piston further in, then those gauges will all move equally, so that everything inside that box, or everything touching that box, is going to be the same psi. It's equal everywhere. Relationship of pressure and volume and heat. As heat is added to a substance, it may increase volume, increase temperature, and increase pressure. No, there's a word that says may. Everything that I know of in refrigeration, every refrigerant I've ever used or heard of, always increases volume, temperature, and pressure when heat is added. And heat is added in a refrigerant. We don't actually heat it up with a flame, or this is heat energy they're talking about. The energy of when that piston pushes up on that cylinder, compressing or making that gas in a smaller space. The energy, heat, increases the volume, increases the temperature, and increases the pressure. And that's what our compressor is made for in the air conditioning system. The next bullet point, if the volume of gas is decreased, it may increase pressure, increase temperature. The only thing that I personally know of that does this, nothing in refrigeration that I know does this, is automobile gasoline. If sometimes when you decrease the pressure, it will, decrease the amount of gas, the pressure and temperature of that gas will increase, because it uses oxygen to do that. But nothing in our refrigeration process will use that. Heat of compression. What this is saying is it can gain without heat or loss of heat. It can in its surroundings. It can change without gaining or losing heat. But none of our refrigerants, again, does that. So if a substance is heated, its volume tends to increase. The effects of pressure on physical state. This is very good information for the refrigeration and air conditioning field. It says pressure affects the temperature at which a substance changes its physical state, where it goes from a gas to a liquid in condensation, or it goes from a liquid to a gas in evaporation. So high pressures require higher temperatures. Low pressures require lower temperatures to change their state. The example is a low pressure in an evaporator. An evaporator allows evaporation of the refrigerant at low temperatures. So it changes it from the liquid to the vapor.